Okay, so let's go ahead and see how you can, I'll give you a name of a substance and come up with the formula. So the first one, let's try calcium carbonate. All right, so how do you come up with the formula for calcium carbonate? Once again, ionic compounds always have two ions. The first ion is right there, calcium. Right? And we just do it like we did before. All right? Calcium, we can find it on the periodic table. It's number 20 on the periodic table. And when we find calcium on the periodic table, we find that its symbol is Ca. And since it's in column 2, it has a +2 charge. Okay? So just like we did with the simple binary ionic compounds. Carbonate is, on the other hand, you cannot find on the periodic table. If you looked on the periodic table, you wouldn't be able to find carbonate because it's not an element. Okay. There's a carbon, but that's different from carbonate. Okay. Here's a tip. If you ever see a substance that ends in ATE or ITE, it's probably a polyatomic ion. And where you find the polyatomic ion? Well, you would find it on the PowerPoint that I gave you guys yesterday. That's like page 38 of 39, almost near the end, is this list of polyatomic ions. And if I go here, I will find that carbonate is right there. So carbonate is one of those polyatomic ions that is made up of a carbon and 3 oxygens. It's a group of 4 atoms, 1 carbon, 3 oxygens that has a -2 charge. So I'm going to write it down as CO3 with a -2 charge. Okay? So you will notice that this is an ion just like this one. Okay? And we're going to do just like we did before. The whole idea is that this substance is neutral, which means the number of positives equals the number of negatives. So if I take a look at the calcium ion with 2 positive charges and the carbonate ion with 2 negative charges, I see that they're an equal number plus and minus. So I don't have to add any of these. 1 calcium and 1 carbonate is enough to balance out the charge. So all I do is put them together, just like I did before. Right, so I write my formula for calcium carbonate as Ca and then CO3. Okay. And that's made up of 2 ions. Even though there's 3 elements in there, one of my ions is actually 2 different elements combined together. So this is 2 ions. And that's your formula for calcium carbonate. Now, sometimes it won't balance out that way, but that's the basic idea. So a lot of times it won't balance out that way. So let's try another one. Okay. Let's try calcium hydroxide. Okay, how do you write the formula for calcium hydroxide? Well, you got to figure out the 2 ions. Okay, and just like before, we still have calcium is our first calcium is our first ion. It's our cation. So since calcium is calcium, it still has a symbol of Ca, and it's still in column 2, so it gets a +2 charge. But now our counter ion, our anion, is different. Now we got hydroxide. So what's hydroxide? Now this one doesn't end in ATE or ITE, but it's one of the 2 that actually ends in I. It's a polyatomic ion. Here's your hydroxide right here. It's OH with 1 negative charge. So I can write this as OH with 1 negative charge. In this case, the charges don't balance. Your calcium has 2 positive charges. Your hydroxide only has 1, which means we need more negatives, right? So how do we balance out? We get, just like we did before, let's say you had calcium and chlorine only had 1 negative charge. You need more chlorides, right? So here we need more hydroxide, so we bring in a second one. And when you bring in the second one, now it balances out. Now we have 2 positives on the 1 calcium ion and 2 negatives on the 2 hydroxides put together. So now it's balanced. Now we want to write the formula that shows that we needed 1 calcium ion and 2 hydroxide ions to balance the charges. So what you're going to do is you're going to write Ca, and then you're going to put parentheses OH. And then outside, close parentheses, and outside the parentheses, you're going to put 2. And that 2 is going to represent the fact that we needed 2 hydroxides in order to accomplish the neutral formula. Okay? When you have a polyatomic ion and you need more than one of those polyatomic ions, you put parentheses around it to show that you need more than one. Let me show you what would happen if you didn't use parentheses. It would look like this, CaOH2, and it looks like you need a calcium, one oxygen, and two hydrogens. It just looks like that 2 belongs to the hydrogen. So by putting the parentheses, now you're saying I need 2 of the O and the H together. I need 2 OHs, not just 2 hydrogens. So that's why we do it that way. Okay? You only use parentheses when you need more than one polyatomic ion. In our other worksheet, the one with the simple binary ones, you might have gotten something like this. Calcium and bromide. Right? Just like calcium and hydroxide, the calcium has +2 and the anion has a -1 charge, so you need 2 bromides, right, to balance out the 2 positives on the calcium. That one you would have written as CaBr2 with no parentheses. But the reason why you could do that is because this is just one element. This 2 goes to this one element. In this one, we want to make sure that people don't think that we just want 2 hydrogens and only 1 oxygen. We want 2 of the whole OH. That's why we need to put parentheses. Okay. So when you have a monoatomic ion, an ion made up of just one atom, you don't need parentheses. When you have a polyatomic ion, you do. Okay. Any questions so far? I'm going to do one more example on that one. Let's say that you ended up with, you want to do sodium phosphate. Okay. How do you do this one? Right. We know sodium is on the periodic table, number 11. Its symbol is Na. It's in column 1, so it gets a +1 charge, 1 positive charge. And that's our cation. The phosphate, once again, ends in ate, ATE. Either ATE or ITE is a clue that we need to look on that chart, or we need to look up the formula for the polyatomic ion. Okay. So phosphate is not, phosphorus is found on the periodic table, but this is not phosphorus. Phosphide is the phosphorus as in, for the negative charge, if it ends in IDE, but this is phosphate. Once again, ates and ites. Ates and ites are found in this chart. So phosphate is PO4 with 3 negative charges. So PO4 with 3 negative charges. Okay? Now in this case, the positives and the negatives don't balance out again, right? We got 3 negatives, but 1 positive. So we're going to need 3 of these guys. Right? We're going to need 3 sodiums, 3 plus 1s, to balance out the 1 negative 3, right? So we're going to write this formula as Na3PO4. Okay. Notice that in this case, I did not use parentheses. Why? Because I only needed 1 phosphate. My polyatomic ion is phosphate. I only needed 1 of those polyatomic ions, so I don't have to put parentheses. I only put parentheses when I need more than 1 of my polyatomic ion. I needed 3 sodiums, but the sodiums are not polyatomics. So this 3, it's easy to see that it belongs with this element. There's just one element here that is followed by a 3. So I don't need to show that. I don't need to do this because it's just one element at a time. Okay. One more like this. Barium nitrate. All right, so barium nitrate has barium in it, atomic number 56. Symbol for barium is Ba. It's also in column 2, so it gets a +2 charge. Nitrate is on the list over here of polyatomic ions. It is NO3 with one negative charge. So there's a barium, and there's a nitrate, NO3 with one negative charge. Okay. Once again, they don't balance out. Two positives on the barium, one negative on the nitrate. It means we need a second nitrate to come in. And when I get the second nitrate in, now we've got two negatives along with two positives. So now to show how we're going to go ahead and how we needed two nitrates, we're going to go ahead and write the formula with Ba. Here we're going to use parentheses, NO3, 2. Okay. Once again, we use parentheses because we wanted to show that we needed more than one. In this case, we needed two nitrates, two of the whole group. Okay. If I did not put parentheses on this one, it would look like this, BaNO3, 2. And it looks like I need one nitrogen and 32 oxygens. Okay, so that's why the parentheses. Okay. So it's just a pretty simple rule. If you need more than one, because of the charges, if you need more than one of a polyatomic ion, like nitrate or hydroxide or any one of those, you put parentheses around it. If you only need one of them, like here I only need one phosphate. The one phosphate had 3 negative charges. If you only need one of them, then you don't have to put parentheses. You don't put parentheses. All right. Any questions on these, putting together these formulas from these names? All right. What about names from the opposite process? All right. The next one. Let's try this one. If I gave you this formula, SrSO3, how would you name it? So on your last worksheet, it was pretty easy to, I think it was relatively easy to name your elements because on the last worksheet you had formulas like KBr, and it divided into two elements, right? The first element was your cation, potassium. The second ion was your anion, bromide, right? It's bromine, but we changed the name to bromide because it's an anion. We gave it the anion name. So this one would be potassium bromide. This one looks a little more complicated because there's 3 elements on here. There's a strontium, there's a sulfur, and there's an oxygen. And I get people giving me, oh, this looks like strontium, sulfur, trioxide, or who knows, you know what. When it's an ionic compound, there's always 2 ions. And you just need to break it up into the 2 ions. And here's a hint. The first ion is usually just a metal. 98% of the time, 98 to 99% of the time, the first ion in your ionic compound is just a metal. So Sr is on the periodic table at number 38. It is a metal. So you separate this metal from the rest of the molecule. The rest of the molecule is made up of 2 elements. But then again, so are those polyatomic ions. So the trick here is now you realize that your polyatomic ion is your anion. And notice this. Most of the polyatomic ions on here, almost all of them, are anions. They're negatively charged ions. So you will get them at the back end of your formula. So the way you name this is, well, Sr is just strontium, so you name it strontium. And SO3, you find SO3 on this chart right here, and it's named sulfite. So you just write it, the name of that one, strontium sulfite. And that's it. Okay. So it's just strontium sulfite. Okay. The key is trying to figure out how you divide this. How do you divide this this compound? But really, the first element is usually a metal, and the metal is separated from everything else. The only exception to this rule that we start off with a metal is when the cation is ammonium, NH4. It's the one polyatomic ion that's positively charged on this chart. There are other positively charged polyatomic ions, but They're not on this chart. We don't see them all that much, so we don't really deal with them much in this class. Okay? Let's do another one. Sometimes you'll get one like this. MgClO3 twice. Okay. All right, how do you name that one? Okay. You should be thankful for the parentheses here. Like, oh, parentheses. What that tells me is that whatever's inside the parentheses is a polyatomic ion. I don't have to worry about breaking this up into the two ions. The parentheses broke it up for me. The cation is just a magnesium, and everything in the parentheses is your anion. Right, so what's Mg? Mg is magnesium. So we write magnesium. Notice I always say is the name of the cation, then the name of the anion. ClO3 is your anion. So let's take a look at what ClO3 is. It's right here. ClO3 with one negative charge is chlorate. Okay. And that's why it's in parentheses, because chlorate has a negative one charge. Let me write it down. Chlorate. ClO3 has a negative one charge. Since magnesium has two positives, because it's in column 2, we needed two chlorates for each magnesium. That's why it ended up being like that. Okay. Any questions on these so far? All right, let me give you the one that always kind of throws people a little bit. NH4NO3. People look at that and go, the heck, how am I going to name that? Nitrogen, hydrogen, nitro trioxide. No. Once again, it's an ionic compound, and it's made up of two ions. And remember I said that your cations usually are metals with the one exception. When ammonium, NH4, is your first ion. So this is NH4 is your first ion here. We're going to break it up like that. This is actually a combination of two polyatomic ions, NH4 and NO3. So all I have to do is look up what NH4 is and what NO3 is, and I will be able to name it. NH4 is ammonium. So go ahead and put this. Ammonium. And NO3 is nitrate. It's over here on, that's right next to ammonium. NO3 right here is nitrate. You'll be using this table a lot. This one. Okay. Either that or you have to memorize them. So I imagine most people will be using the table. And once again, you can find that one on yesterday's PowerPoint that I put up. It's on the second to last page. And I'm sure you can find them online all the time. Okay, so ammonium nitrate. Always, like Yoda says, always two there are. There are always two ions. Okay. Any questions on naming elements with polyatomic ions in them? Really, all you have to do is identify what's a polyatomic ion. And what I do is I go, oh look, there's more than two elements in my formula. There must be a polyatomic ion. Because if it's just two elements, there's no polyatomic ion. One of them is a cation, and one element is the anion. But if there's more than two, then we have to figure out, well, what is your what is your cation, what is your anion? Usually, the polyatomic ions are anions. Then the cation will be a metal, with this exception. Whenever NH4 is at the front. And you can pair NH4 with any monatomic ion like chloride or bromide or oxide, or you can pair with other polyatomic ions like carbonate. But as long as NH4, it'll either be a metal or NH4 that's at the beginning of your formula if you have an ionic compound. Okay? All right. Any questions? All right.